Fire alarm, schmire alarm. I bet they had all the fire test cases and they forgot the water one. One of those edge cases that only a tester would have found. All right, you all ready for Lightning Talks Day 2? What about Tony and Simon? How did we do this morning? All right, all right, all right. Now later I'm going to make Tony and Simon leave the room and I'm going to ask you again what you thought about the morning. Okay, here we are. We have kind of a Mozilla Google sandwich going on here. It's going to be Google, Mozilla, Google, Mozilla, Google. Don't get the idea that we like each other particularly much. Don't get the idea that we dislike each other particularly much either. I think they have a browser. You have a browser, right? Mozilla? Yeah? Netscape? Is that what it's called? No? Something very foxy and very on fire. Okay, so same rules as yesterday. Dounia Berrada from Google, you're up.
Hello everyone, my name is Dounia and I'm an engineer at Google. I work in the Eng Tools teams. So today I'll be talking about Android testing, and especially native and web apps testing, and then I'll say a couple words about very basic setup in the clouds. Let's take a look at native apps testing. Android, when you build an Android application, there are three main aspects you want to look at. One is functional, performance, and then the responsiveness of your application. When you look at functional testing, Android has two great APIs, which actually their instrumentation framework, which is the Android instrumentation framework and the accessibility instrumentation framework. And they provide a set of hooks into the operating system that allow you to actually interact with your web application like a user would do. Some of you may be more familiar with Robotium, which is actually a wrapper around those instrumentation framework and delegates call to those APIs. Then if you want to do performance testing, there is the performance test case class, which allows you to collect great latency data about your application. There is DDMS, which lets you look at, for example, how much heap memory a thread is using at a particular point in time. And there is something called TraceView, which is a great tool to know when a thread or a method starts and stops. So you kind of can monitor the entire state of your application throughout the execution of your test. For responsiveness, there is an API called strict mode, and this is a great API to actually detect any illegal behavior, especially when you want to ensure that your application is always responsive. So, for example, it will signal when the UI thread is too busy doing some network or disk access. For web application, we use Selenium Webdriver, which has an Android implementation. And the nice thing about it is that we also support native events when we interact with the DOM. So this means that any user interaction, like any touch action that you send to interact with your web application, is going to use native key and touch events. So we don't substitute that with JavaScript to interact with the web application. We also have HTML5 support. Let's quickly take a look at what the code would look like. So for example, here we have a Google image, right? And we're gonna flick an image across the screen. We're gonna make sure that the next image is displayed, and then we're gonna rotate the device. So we can do that with WebDriver APIs. Just like you can see, first we look up an image by its HTML ID. And then we're going to create a flick action by 400 pixels horizontally across the x-axis. And then we're going to look up the second image, make sure it's displayed, and then call rotate on the driver to rotate the screen and make sure that the image has been resized. So this is giving you a taste of what's possible. For Android WebDriver, we actually give you this in two possible flavors. One is you can run the test remotely. The other one is running the test on the device directly, which means that, so when do you choose what? Running the test remotely is great because it allows you to use any of the Selenium Webdriver bindings, meaning that you can write your test in Java, Python, Ruby, and any other language binding Selenium Webdriver supports. Running the test on the device directly is a lot faster, but at the same time, you can only write the test in Java. So if you're OK with that, choose the second one. So a quick word about the cloud. Android emulator is nothing but a virtual machine which can run on most operating systems. So if you have a cloud setup, you can fire an Android VM on those machines. Typically, you want to have one test at a time per emulator, and you want to fire an emulator when a test request comes up. So you can also start up multiple emulators per machine, as Simon mentioned earlier in his talk. So because Android emulator is an emulator, so it emulates the entire virtual machine, including the virtual CPU, MMU, it actually can be really slow, especially when compared to the iOS simulator, for example, which doesn't try to emulate anything, so it runs on your Mac at full speed. So there are things we can do actually to make the Android emulator a bit faster on your cloud setup. Especially, you can disable all the cosmetics, and you can start the emulator from a snapshot image. This drastically improves the performance. I think an emulator starts in 2 to 3 minutes. With the snapshot, it can start in 2 seconds. Thank you very much.
Well done, Dounia. Next up, we have someone from Mozilla. David Clarke, you're up.
Okay. Can you hear me? Okay, you can hear me, great. Okay, so I am David Clarke. I work at Mozilla. I'm in automation services. And the project that I've been working on is jstestnet. The purpose of the project is to be able to test JavaScript integration tests in the cloud. So let's move it along. Okay, so the first thing is JavaScript integration tests are difficult. There's problems in how you execute JavaScript tests, what language you're going to write in, and how you're going to report those results. So this is not a niche problem. It's going to show up in a lot of new web apps that you're creating. It's going to show up in a lot of web services that you're creating. You're going to want to be able to test JavaScript because JavaScript is doing more now than it's been doing in the past. And sometimes jstestdriver is not enough. We want to be able to test JavaScript in more invasive ways, and it is enough, but sometimes you have to change the tool for what you're trying to accomplish. And so regressions are not typically have been a problem in web services. You just push code to your web services, restart your web services, and the client side is usually fine. That is not always the case right now. So what we've been looking for is a framework that supports a few different things. We are interested in continuous integration. We want to be able to report our results. We are interested in, we'll just let that keep running. We won't even bother with that anymore. So we're interested in continuous integration. We're interested in a simple framework that's extendable. We were interested in finding an environment that was deployable and we could run over Jenkins continuous integration. So this is the architecture that we had, that we set up in our lab environment. So Jenkins continuous integration speaks to jstestnet lib. jstestnet lib speaks over our JSON wire protocol to our jstestnet server, which attached to that is many different browsers. So I've listed pretty much all the important browsers that I could think about. If you can think of any that I forgot, just send me a tweet or something. But the interesting thing about this architecture is it allows us to change out different pieces that we find are interesting. So jstestnet lib is actually powered by nose tests. Is anybody familiar with Python test environments? So nose tests, it allows you to completely rewrite how you want to report your results. So you could report them in a JUnit manner. You could report them to whatever kind of environment that's interesting for you. So once again, we'll forget what's going on up there. So that's very nice. And then there's also another capability, which is extending the jstestnet server to do more interesting things on the browser end, and we'll talk about that. I guess one of our problems with running our continuous integration was our tests required hidden iframes. So we have many different iframes, and they're all talking to each other. And that was actually quite difficult to do in jstestdriver. So we went around and we started looking for other test frameworks that would enable that. I guess framework extension capability is there, but only along certain axes that we care about. And one was reporting, and the other was allowing us to write our tests in different languages. So we wanted to, so the opportunity was this project was to improve our integration testing capabilities. We wanted very HTML5-ish kind of capabilities. We wanted to be able to inspect the DOM. We wanted to be able to, wow, that's quick. OK, well, I guess my time is up. Thank you.
Well done, man. Love it. You might get an extra couple seconds off his last slide. So this is Matt DeVore, NativeDriver from Google.
Hi, my name is Matt DeVore, and I'll be talking about my project, NativeDriver. NativeDriver is an open source library for testing the UI of native applications for Android and iOS. At Google, we have had many pain points with existing test tools, and I'll explain what those are and how they lead to the idea for NativeDriver. Then I'll tell you what NativeDriver is and how it fixes those problems. So then we'll look at NativeDriver's architecture, and I'll show you how you can try out NativeDriver yourself, then share with you the current state of the project. So what is wrong with current test tools in common use? First, each platform you want to test requires the use of a different API. If you test an app for both web and iPhone clients, for instance, you'll probably be using WebDriver and then UI automation for iOS. So a recent trend is also to use image-based test tools. In image-based tests, there are images embedded in the code, and the test driver performs operations based on where those images are located on the screen. But then when you try to support new languages or platforms, the number of images skyrockets, and you have to update images all the time. So also, the language used to write the test and the application are often different, which makes more knowledge necessary. And we also have a trend to embed web content inside the native app, and we want to also handle that in a nice way. So one thing, so to sum up the difficulties is that you need a lot of extra knowledge because of all the APIs and languages. And there's a recent trend that we want to handle native and web content in the same app. And also the large number of languages you need to know. So NativeDriver is an attempt to address all these issues. It is a multi-platform solution for testing native apps, and each platform implements an extended WebDriver API, which is shared between all platforms. So here is a sample test of NativeDriver. And you can see we start out with start activity, which is a lot like going to a URL in the browser. And then we do a common pattern in WebDriver tests, which is find an element by some property and then perform an operation on it. These are all normal WebDriver API calls. And the other thing that this test does in the next slide, it rotates the screen, which lets you test in landscape mode. This is another common Android API call. So far, we've only seen one new API call that we've had to make that's foreign to WebDriver. So next, I'd like to show you the architecture of NativeDriver and show you how it builds upon existing test tools. So test execution is comprised of a server and a client. And the server is the app, and the Android device, and the client is the test. The server and client communicate through two channels, the Android debug bridge and the WebDriver wire protocol, which is based on HTTP and JSON. And the Android debug bridge is a common Android testing utility, which allows you to inject events into the device, but it's not easy to get UI information out of the device. And the instrumentation is driven by the wire protocol, and that can get more info out of the device, but it has some security limitations. So instrumentation is generally very low level, and it requires knowledge of the app, so it's white box testing. Android Debug Bridge is not a full testing solution, but it's a utility to communicate with a device or an emulator by the command line, and it's useful injecting events, and it doesn't have the same security problems as limitations of instrumentation. So if you compare these two side by side, You can drive many platforms and native application tests with a single API, and it's totally black box. And using existing WebDriver language bindings, it's easy to support any language that you want. Because all tests unify with a single API and language, then you have more opportunity to share to share code between several different tests. So you can try out NativeDriver yourself by going to nativedriver.googlecode.com, and it's download from there. There's also getting started tutorials and demo videos, and for both platforms that it supports iOS and Android. You can also communicate with other people on the mailing list. There are links from the Google Code site there. And please ignore the slide. I didn't have time to talk about it. So our next steps for this project, for iOS version, we want to create Objective-C client bindings and implement advanced gesture support and screenshot support. And for Android, we're working on plugin support to support custom UI controls and OpenGL views, for instance, and also web view support to make the connection between web and client testing. And that's everything. So thank you.
Great job, Matt. All right, next, David Burns from Mozilla.
So my name's David Burns. I'm a lead software engineer and test at Mozilla. And today I'm going to be talking about how we could possibly generate heat maps while our WebDriver tests are running. It's come around from a number of managers going, oh, I've seen these WebDriver tests running. Can you tell me what coverage they have? And normally, as an automator, developer, or tester, the answer is always the same. I can't. But how about you take my word for it? This doesn't always fly with managers. They like shiny things. They like images. You know, we have to solve these problems. So what we'd like to show when we run our tests is something like this. This is just taken from usage stats from Firefox. But it kind of shows where people are clicking around the browser, things like that. And in theory, it should be fairly simple to do with WebDriver, because we should know where all these things are. OK. So the problem is that, like, with WebDriver, well, it's not a problem. WebDriver is great because it can tell us everything that we need to know about what's happening on the page. We have full access to the DOM. We know where all the elements are on the page, which is great. So we can just go, oh, I need this element, bring it back to me. WebDriver also knows the size of elements on the page. So you've already told your test that you need this element. You then go, can I have the size? And because it knows the DOM and everything, it's pretty pinpoint where it can say where on the page this is, where its location is. And because WebDriver is great, it can take screenshots. So now we need to kind of mash all of this together to get the product that we want. So what are the things that we need to put together? So we need to kind of override the web element object because we have WebDriver is split into two main objects. So you have your driver, your web element, or your element. And so when we get it, we need to get all this information. But as we use the element, we need to take a screenshot, get its size, get its location. And we need to store all of this information. There is one downside to this. Taking screenshots is quite heavy. It uses a lot of disk space and to get all of it. So we also need to now solve the problem of collecting all this information and making it useful. So a good example is I click a button, there's a reflow or a render on the page, a div comes up so that we can interact with that. Do we need to carry on with it? So we need to solve that problem. Well, so because tests are running, we don't want to impact how quickly the tests are running. We want our tests to still run as fast as possible. So we need a separate processing system so that we can collect, like once the test is finished, we then have all of it and then process it and have our test to do it. I have a proof of concept kind of working, so if you have any questions, please come find me. Cool. Thank you.
Faster than lightning. Next up, Jerome Mueller from Google Zurich.
So I try to speak slow, but I make no promises. Okay. So my name is Jerome Mueller. I work on Google Calendar. And today I'd like to tell you about how we write our tests in plain English, and why we do it, and how we automate those tests. About a year ago, calendar development moved to our team, and my job was to look at the automated tests. So I looked at them, and the very first question I had is, what exactly do those tests actually cover? So I looked at them a little bit closer, and the tests, the Selenium tests, are very fine-grained. It's click here, enter some text there. And it's a lot like looking at a picture from very close, and it looks all pixely, and you can't see the full picture of it. So we decided to separate the what is being tested from the how it is being tested, and we wanted to use plain English for the what is being tested and use Java and WebDriver for how it's being tested. So we turned to behavior-driven development to rescue us, and BDD tells us to write usage scenarios, essentially saying the what needs to be tested without worrying about how it's going to be tested. It also suggests to use the words given, when, and then to start your sentences. So you end up with tests like, given an event, when I delete it, then I do not see it anymore. That's a very simple case. So we wrote a few scenarios, and we tried to keep them very high level, very easy to understand. And the syntax you see here is actually taken from Cucumber. So we heavily relied on that. Then we started implementation of those sentences that we just wrote, of those scenarios. And the way it works is that we have Java methods which get annotated with regular expressions here, and the group gets then mapped into the method as a parameter. The methods themselves are very, very small. They just contain the actions that are needed to execute that one sentence. So we delegate to page objects really quick. After about 60 scenarios, we had a little milestone reached. We were able to submit a test script without actually touching any of the Java code or Java testing code. At that point, we wanted to also involve the manual testers and our engineers in writing the tests. For the engineers, we actually had to add a little rule that they can't release a feature without adding an end-to-end test. We found out that this whole approach has quite a few advantages for us. For example, it's very easy to understand why a test fails. It's easy to see where it fails, and it's very easy to manually click through and see what actually happens because I have all the steps there. Now, it's also very easy to find out what the overlap is between our manual test cases and our automated test cases. Because they're both in English, I can delegate that task to anybody. It's easy to understand. We ended up with well-structured code. We have the English, what is being done on top. We have the sentence implementation, the actions that every sentence needs to have. And the bottom part is the page objects. When they contain a test script reviewing a coherent set of code changes to be submitted in an atomic operation, also known as change list, is easier to understand than this sentence. And the reason for that is that the test script contains a summary. So we had some problems too. Refactoring the sentences is kind of hard because we don't have IDE support, and we don't use the sentences in any of our API tests. So in the future, I want to take this whole thing a little bit further. We're not there quite yet. But I want to free our manual testers. They shouldn't do any regression testing anymore. They should be more involved in automating tests. and have more time for exploratory tests. Then I also would like to think a little bit bigger. I'd like to have sentences that can be used across projects. A lot of projects have to think about the same things, like security, accessibility, and other things. So I would like to have sentences that say, then the contrast is good, or then the page looks good in for bidirectional languages, as we have heard yesterday. And I would like to take it even one step further and help make cross-project integration tests by having sentences like, then I +1 this, or when I +1 this, then XYZ gets shared on my stream. My 5 minutes are up. Thank you.